Hello, good morning viewers. In this tutorial we are going to learn how to find the gradient of an implicit function. So what we are given here is we are asked to find the gradient of this curve. This is an implicit function because both x and y are expressed implicitly. And we want to find this gradient at a particular point where the value of x is equal to 2 while that of y is equal to 1. This is only because the gradient of a curve is not constant, unlike a linear graph. So let's begin. The first thing we need to do is to differentiate this function implicitly, applying chain rule. We are going to differentiate every term independently. The first term here is 2x squared. If you differentiate that, this power will drop down to multiply. We have 2 multiplied by 2 equal to 4. And the power will reduce by 1. 2 minus 1 equal to 1. Minus. But here you can see we have x and y. They are independent functions. Therefore, we are going to treat them using product rule. So let me factor out negative 4. Then inside, we are going to differentiate the 2 terms using product rule. We keep one constant, we differentiate the other, then we keep the other constant, differentiate the first one. So let us keep x constant, then we differentiate y. If you differentiate y, you're going to obtain 1. But remember, an implicit function, whenever you differentiate y, you have to multiply by y prime or dy over dx. So multiply by y prime. Now we are going to add, keep y constant this time around and differentiate x. Y constant, if you differentiate x, you're going to obtain 1. Y times 1 is still y. Moving on to the next one. These 2 will multiply 3. We have 6. Y raised to the power of 2 minus 1. 2 minus 1 is equal to 1. But this is y again. We have to multiply by dy over dx. But remember, I was using y prime. This is equal to the derivative of a constant is 0. So we have 0 here. Okay, next. Let us expand this bracket. We have 4x. Minus 4 multiplied by xy prime. We have negative 4x y prime. Minus plus is minus. 4 times y is 4y. Plus this other term, 6y y prime. And to the right we have 0. Next, we are going to bring those terms that contain y prime. We have one here and we have the other one here. But we can write this one before this because this is negative. So we have 6y y prime, then minus 4x y prime. And we can decide to take those terms that does not contain y prime to the right. Taking negative 4y to the right, it becomes positive 4y. Then we have another one here. It is positive here. To the right, it is going to become negative. We have minus 4x. Now we are going to factor out y prime here. We have y prime outside, then inside. For the first time here, we are left with only 6y. Minus here we have 4x. And this is equal to 4y minus 4x. Next, we divide both sides by 6y minus 4x, leaving only y prime to the left. So we have y prime to the left, and this is equal to 4y minus 4x divided by 6y minus 4x. 6y minus 4x. Now we have just obtained the derivative, which is dy over dx. But remember, we are asked to find this gradient at a point where x is equal to 2 and y is equal to 1. So we can say at x is equal to 2, y equal to 1. We are going to substitute these two values in this equation. So we have dy over dx, which is the same thing as y prime. This is equal to 4 multiplied by y, and y is equal to 1. So we have 4 multiplied by 1 minus 4 multiplied by x, but x is equal to 2. Divide by 6 multiplied by 1 minus 4 multiplied by 2. Let us simplify this to obtain our gradient. So let me do it here. 4 multiplied by 1 is equal to 4. dy over dx equal to 4 minus 4 multiplied by 2 is 8. Divide by 6 multiplied by 1 is 6. Minus 4 multiplied by 2 is 8. This is equal to 4 minus 8 is negative 4. Divide by 6 minus 8 is negative 2. But negative 4 divided by negative 2 is equal to positive 2. Therefore, dy over dx at that point is equal to 2, which is just the solution to this problem. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.